Now this is a graph of resistance versus L. Okay, so that means the gradient of this graph is rho over A. That means we will have to always use the same cross-sectional area of the wire. So we are using the same wire but different lengths of that wire. Okay, so if I write this here, now we can also learn this in detail when we are doing the actual lesson. So what we will do is we will use the same wire but different lengths. So same wire means resistivity will be the same. Okay, and since we are using the same wire, the area of cross section will be the same. So here you can see we'll write this as rho. That is the constant for a certain material because we are using the same material of wire. So but we will use different lengths of the wire. So maybe this is a longer one. So we are not just using two, we are using several. You can see there were several lengths that were used in the example that was shown. Okay, so here this is but we know the length. Okay, then what we will do is we will plot a graph of R versus L. Now you know the relationship according to this equation. If rho and A are constant, when L increases, R increases. So here we have R, here we have L. Now let's rearrange this, okay, because I'm plotting this graph. Just move this here. Okay, so you should also know how to do this rearranging depending on the graph you're going to draw. Okay, so first, now this is the first equation you will learn, and there is only one equation that you will learn that has resistivity, and that is this equation. And regarding the drift velocity, you will learn only one equation that has the drift velocity, that is the transport equation. Okay, so what we will do is we will write this R equals rho L over A. Again I am rewriting the same thing, but you can see now I am plotting a graph of R versus L, and I told you the area of cross section is the same, and since we are using the same wire, rho, the resistivity, is also the same. So I can write it like this and draw a square bracket around it to indicate that rho and A are constant. Or I can write the square bracket for rho, the square bracket for A, which indicates both of them are the same throughout the experiment. Now you can see that since this is constant, we can also say R is directly proportional to L, which is what I wrote over here. So directly proportional means that when you draw a graph of R versus L, it should be a straight line passing through the origin. See whether I can draw a line, straight line here. Yes. So it should be a straight line passing through the origin because it is a direct proportion. Direct proportion means that it has to fulfill two conditions. One is it should be a straight line. The other is it should pass through the origin. Okay, so this is what they were mentioning about, that is the graph. Now you may this is the easiest way to do it. Now you can also have same length but different cross-sectional areas, but that is a bit difficult, right? You have to get the same material wire, same length but different cross-sectional areas, different diameters, but that is not something easy. Instead you can simply, let's say, get a copper wire and then a long copper wire and cut it into different lengths. So that way you can get different lengths, and after that you can find the resistance of each wire, copper or some other wire, and you can plot the graph. So you can get the resistance using an ohm meter. By the way, I have uploaded a video explaining how to use the multimeter as an ohm meter. If you watch that video, you will learn how to find the resistance of a resistor. Even the resistors have a material inside it which is a conducting high resistance wire. So you can watch the video on using a multimeter as an ohm meter to find resistance. Now let's go back to the lesson. Yeah, so you can see here several values are taken, 1, 2, 3, 4, 5, 6, 7, 8, 9 readings, And before you draw the graph, make sure you first tabulate the results. You can write in a table. I will just show it here. You can actually write those 6 values in a table. Let's say I have a table like this. Okay, then over here I have 2 columns. One is the resistance in ohms, and the other is the length of the wire in let's say meters. So here also then I will need to write the unit in ohms and in meters. Now you can see we always plot the independent variable in the x-axis and the dependent variable in the y-axis. The resistance depends on the length of the wire, not the other way around. The longer the length, the greater the resistance. The shorter the length, the smaller the resistance. So the resistance depends on the length. Therefore the length is the independent variable and the resistance is the dependent variable, since it depends on the resistance. Then we can get those 6 values. You can draw, make sure you draw all the borders also for the table. So 1, 2, 3, 4, 5, 6. See, we have 6 readings. Then we can draw it like this, and once you have all the values, you can plot them as you can see over here. And from that you can see the gradient of this graph. Okay, then you get the gradient. Now you can see this is R versus L. It's in the form y equals mx. I'll write that here. I'll use a different color, then it's easier for you. So what we have is, this thing I will write it here. R equals rho. Now that rho is a constant because it's the same material of wire. A is the area of cross section of the wire, that is also a constant, times L. So here we can, under this I will write y equals mx. You know, y equals mx plus c. I can write plus c, but c is the y-intercept, that is 0, because it passes through the origin. So here there is no plus c part, or we can even write plus 0. Here also plus c, but c is 0. So I don't need to write that. Now you can see that on the y-axis what we have is r. See, r is on the y-axis. Then what we have on the x-axis is, what we have on the x-axis is L, the length of the wire. So x is L, and the gradient is this, that is rho over A, the resistivity divided by the cross-sectional area of the conductor. So we can now, once we know the resistance, once we find the gradient, okay, once we find the gradient, we can find the resistivity, because area of cross section we can use the formula pi r squared, or since r is what, okay, wait, I will first write this, then it's easier. Now radius is diameter divided by 2, so we can write this as diameter divided by 2 whole thing squared. That is the radius. Okay, now how do we measure the diameter? We can use a micrometer screw gauge. Now if you don't know about micrometer screw gauge, you can search my channel. On the channel there's a video explaining how to take measurements from a micrometer screw gauge. You can watch that, and also there are so many other videos online that you can watch explaining to you in a few seconds or in a few minutes. They explain how to use the micrometer screw gauge. So using the micrometer screw gauge, you can find the diameter of this wire. Remember, we don't take just one, we take it at several places along the length of the wire in different orientations. Maybe initially you can measure it like that, then next step you can measure it like, on the other side like that. So is it this way, then 90 degrees like this, like that. You can take it in different orientations, and then you can get the average diameter, plug it in here and get the area of cross section. So you can find that, and gradient of the graph you can find that, you know how to do that. and then you can get the resistivity. So if I write that here, the resistivity is equal to, if I make this the subject, one more thing, I'll just write this, M is equal to rho over A, right? Then A is equal, rho is equal to the gradient times the area of cross section. So I can find the area gradient from the graph, and I can find the area of cross section using this method. Then I get the resistivity of the wire. So this is how you find the resistivity, and that is actually what is explained over here, how to find the resistivity. And you should know the definition also of resistivity, and it is explained here. Now let's just go back, and also you can see over here different materials have different resistivities, and here you can see this is what is continuing. Now this is what I explained. Using the micrometer screw gauge, you can find the diameter. Once you know the diameter, you can find the area of cross section, and after that you can find the resistivity using the method I told you. But by the way, here what they are doing is, instead of using an ohm meter, they are using a ammeter and a voltmeter. So this is something that will take more time, but what I instead do is, you can directly connect the ohm meter. So remember, if you are using an ohm meter to find the resistance, you connect the ohm meter and that instrument only. You don't connect anything else. If you are finding the resistance of something using an ohm meter, you connect only the ohm meter and the material you want to find the resistance of. Nothing else in between. Now I have uploaded a video on explaining how to use the ohm meter, how you can use a multimeter as an ohm meter to find the resistance. You can watch that video, then you will have a good understanding of how to use it. Otherwise, you can do it this way. You can find the current through this. Now you can see here, this is the power supply, and you can see it is in series with the wire. See, whatever current that flows through the ammeter is flowing through the wire. This is the ammeter. Ammeter is connected in series, and here you can see the voltmeter is connected in parallel. In parallel across both of these, but here the potential difference across the ammeter is negligible because it has negligible resistance. So this voltmeter is actually giving the potential difference across the wire. You can see the voltmeter is connected across the ammeter and the wire, but since the potential difference across the ammeter is, we can say, 0, the voltmeter gives the potential difference across the wire. So the potential difference across the wire is measured, the current through the wire is measured, then we can use Ohm's law, V equals IR or R equals V over I, to find the resistance. I will just write that also here. Otherwise you can simply use a ohm meter. So V equals IR means I equals V equals IR, then R equals V over I. So once you have V and the corresponding value of I, you can do that, and for different values of V you can get the corresponding values of I and get the values of R. And remember, for each value of R you have to see what is the length of wire used. Yeah, so that is how you find the resistivity. Now make sure you answer all these questions, and yeah, so let's see what we learned here. By the end of this section you should be, now remember this is 3.1 part 4. By the end of this section you should be able to define resistivity. Now remember, the definition is given here. I have mentioned earlier, you should memorize the definitions with understanding. The resistivity of a material is defined as the same value as the resistance between opposite faces of a cubic meter of the material. That is the definition according to this book. Explain how to measure resistivity experimentally. So I explained that. Make calculations of resistance using resistivity. So how do you find the resistance using resistivity? You can do it like this. See, very simple. Using the formula R equals rho L over A. Now remember, only one equation has the resistivity, and that is this equation here. If you rearrange this equation to make rho the resistivity the subject of the equation, you get this. And here is a simple calculation. The radius of the wire is given. The cross-sectional area can be found using the radius, because our area of cross-section is the area of a circle in a wire. I mentioned this earlier, because wire is cylindrical. So if you cut it, the cross-sectional area is a circle, area of a circle. Then remember to convert this to meters. Now remember, I showed you the method also. 10 to the power minus 3 is meter. So this will be 0.2 into 10 to the power minus 3 times m. So that will give us this 2 into 10 to the power minus 4. Substitute that. Now this is in SI units. So if everything in the equation that you use is in SI units, the final answer will also be in SI units. Now in this case it will be in square meters. Now you can substitute it here. See, the length is given and the diameter is given. Okay, so from the diameter you divide by 2 to get the radius, and then you do it. Now resistivity, you can get it from the table. That is 1.7 into 10 to the power minus 8 ohm meter. Ohm meter is the unit of resistivity. Actually you can figure out the unit by making rather subject of the equation, the resistivity the subject of the equation, like what I've done here. Maybe I can show you that also quickly. Let's see that. Unit of resistivity, that will be what? Unit of resistance, that is ohms. Then unit of area is square meters, unit of length is meters, so we will have the unit of resistivity, that is ohm meters. That's how you get the unit of resistivity. Alright, okay, so we have all this, and you can see the calculation. Now very simple, you substitute and then you will get the answer. Okay, so now make calculations of resistivity using resistance using resistivity. We went through that. The general property of a material is to resist the flow of electric current, is called resistivity. The general property of a material to resist the flow of electric current is called resistivity, which has the symbol rho, the Greek letter rho, and SI units, ohm meters. I showed you how to get the units, and also it's better if you're familiar with the Greek alphabet, because we use a lot of Greek letters in physics. There are 24 letters in the Greek alphabet. The first letter is alpha, second letter beta, third letter gamma, and the last letter is omega. Then you can see here we have resistivity even for non-metals and also semiconductors. Okay, so here you can see the equation. Resistivity is a property of a material. All samples of the same material, regardless of their shape and size, will have the same resistivity, whilst their resistances may be very different. Then we went through an example using that equation, some calculations, how to find the resistivity we went through. Yeah, so that is the end of that lesson on resistivity. Make sure you answer all these questions and check the answers in the answer script. The definition is here, and the next one will be conductance and resistance, chapter 3.1 part 5. We just finished chapter 3.1 part 4.